Thank you, Mr. Chairman. I will present you the works realized in the lab of Lyon with Emmanuel Ferrier and collaboration with the University of Salerno with Enzo Martinelli and Giovanni DULUCCIO. The topic of my presentation is the reinforced concrete walls reinforced by natural FRP in seismic application. FRP in construction used usually CFRP, aramid, and glass fiber reinforced. And the behavior usually is essentially elastic. The steel are elastoplastic. Used composite in different application. Bending reinforcement with the wrap of composite in the tensile zone, bottom of beams, for example. The shear reinforcement in the lateral faces of beams, CFRP, GFRP, aramid, or in confinement again. The question is how substitute classic fiber, natural fiber with the classic fibers. The natural fibers used in lab is the flax fibers. And the flax fibers are a low environmental impact in the human toxicity, aquatic toxicity, climatic warming, or acidification. Donc it's very interesting for the environment. The low density of fiber is very important again. 1.5 or the GFRP is 2.5. The resistance and tensile strength is 9,000 megapascal. The good specific characteristic, the specific modulus and the specific strength shows the flax is equal to the glass fibers. And in France, the disponibility in Europe of flax, because France is the first world producer of technique flax fibers, so it's very important for the France to develop this technique. Flax fibers application. The flax is used in industry of sports with boats, bikes, in domestics, automobile again, and the electronic part of protection of smartphone, for example. The question is in construction is very interesting for us. In construction, the flax FRP exists, yes. But is in no structural part, isolation, for example, or doors or windows profile. The question in the structural application, but it's a great idea if the good mechanics property of composite is real, and there are again the good bonding property in carbon. Bonding properties. In laboratory, since 2013, 2 PhD are realized. The first PhD is realized for determine the materials properties of composite, and 2 works. The first is determine the characteristic of composite with the modulus, the strength resistance. And the second task is to determine the comportment, the behavior of bonding properties. In the 2 cases, the works show that flax fibers is very interesting for structure reinforcement. The second PhD is realized for determine the behavior of shear reinforcement in beams in totally 20 beams are realized with different configurations of number of layers of flax, the distance with strips, different dimension of beams again, and the works show a good efficiency in shear behavior, equal to the resistance with CFRP, for example, or GFRP. For the reinforced concrete walls, since 2011, there are more results in this type of walls. Two types of walls are realized: slender walls and shear walls. For reference and CFRP configuration, 6 walls of each type of walls are realized with different configuration of reinforcement of CFRP. The goal of this work is to substitute the CFRP with FRP. In this case, three configuration of slender walls are realized and one short wall again. The test loading is simple. One axial load is applied in the head of wall. This load is constant in time, and after we applied a cyclic lateral loading with the cycle in the figure, and the acquisition of result show the effort, maximum effort, and the deflection in the head of wall. For results, we show we can see in the figure the red line is the reference wall with a capacity of 27 kilonewton, and the three configuration of walls reinforced by flax fiber. In each case, the resistance of flax reinforced concrete walls is multiplied by 2 of reference loading. For the short RC walls, the same configuration of a curve. The red is the reference, and the green line is the walls reinforced by flax. In this case, the loading increased to 35%. For comparison with CFRP, the red line is the reference wall, no unreinforced. The line orange and pink is the configuration with CFRP, and the green line is the configurations with flax. We can see the good behavior of flax. The loading of flax is 1.3 for the reference with CFRP. The difference between the two solutions is again in the rinse of walls. In the carbon configurations, the rinse appear to debonding of CFRP in the surface of walls. In the flax rinse, the break appear to in the layup of flax. It's rarely a rinse of carbon. It's not debonding. For RC walls short, In red is the reference, and the blue and yellow is carbon, and green is flax. In this configuration, carbon reinforcement and flax reinforcement is equal in the result and in the type of rings of walls. For energy dissipating, we can see the difference between flax and carbon. The maximum dissipation of energy is for the configuration with flax fibers. After, we can see in the slide two types of modeling for slender walls and shear walls. The first method is used in addition for the moment, for the bending, and we can see a difference with the modeling and the experimental result equal to 10%. For shear walls, the technique used is to cumulate the shear contributions of concrete, steel, and fibers. And in this case, the difference is equal to 10% again. So the two models are validated for flax fibers. In conclusion, using flax FRP is an alternative solution because mechanical properties are adequate for structural reinforcement, the good bonding properties in carbon support, and a good efficiency in reinforcement shear, similar to CFRP, good efficiency in reinforcement of reinforced concrete walls, better than CFRP. Flax is FRP perfect. The questions? Maybe. Still many questions. Durability, fatigue, creep, and so on. Thank you for your attention.